G'day guys, welcome back. This time I've got a different one for you guys. I've got a Samsung phone charger here it's mine, and the problem is it will work for a little bit and then it will stop working. So it's not really much for a diagnosis video because it works and then dies after a little bit. I already know what's wrong with it. It's not like it doesn't work at all and there's a blown component like a shorted diode or switching control. It doesn't work. But I'll just show you guys. If you look at my multimeter with this guy powered up, there's 5.007 volts on it. Right, one moment. See, 5.008. That's running. Yes, that is 240 volts on these beefy looking croc leads. No, I would not recommend anybody do this unless they are very, very comfortable around power and competent working with it. If you get this across your body, especially across your heart, and there's a lot of easy ways to do that. You could just touch that active wire and be grounded and be dead. So just don't do this unless you guys know what you're doing. The other thing to be cautious of is with this sort of a board, you might notice there's a little plastic divider there and a white line. That's actually indicating the high voltage side from the low voltage, the low voltage side from the high voltage side. So you always want to check across the capacitors on the high voltage side. So 0.16, there's discharge resistors on them, so they're discharged, that's fine. But you want to make sure there's no high voltage on it, so that when you go and touch it, you don't, that probably won't kill you, especially if you touch it one hand. It won't kill you, but you know, it will hurt and make you jump and go, fuck. And you don't want that to happen. So, first thing to point out, the hole in that capacitor was not already there. I could not get the lid off. As you can see, it was, I don't know if it was ultrasonically welded or glued and I don't know. It's like it's all one plastic piece. Like I've never had one that was harder to pull apart, and it took so much force. I ended up smashing this corner out of it and stabbing that capacitor. So that's why that's stabbed. However, that's not a problem because that is the output capacitor and I'm changing that anyway. I'm going in with a better one. The one that was in there is a 33 microfarad 12 volt. I'm putting a 47 microfarad 50 volt in there. I think that's a solid polymer cap, and this is either just a wet electrolyte, or it might be a hybrid. I might not use that cap. I might actually, what I'll do is I've got all different types of caps. If this is a a dry cap, I forget what they're called, I will check out the ESR and frequency response characteristics of it, and if this is not up to scratch, I will not be putting that capacitor in there. So anyways, on with the work. It's only capacitors. There's only this little capacitor here, this capacitor here, and these two bulk caps on the input. We'll start off. We'll see if we can get a reading of the bulk capacitors. Again, guys, do not take an LCR meter near capacitors unless you're 100% certain that they are discharged. That will really ruin your day. Well, it'll ruin your day and your LCR meter. You don't want to do that. Yeah, those capacitors are good. So it's not the bulk caps. I had a feeling it wouldn't be because the bulk caps are only saying a little bit of 100 hertz ripple on them. The output cap is saying high frequency pulsing from the switching converter, and that causes it to fail a lot quicker than what these do. But because these are Chang, some Chinese brand caps, I thought I'd test them just in case they had failed. Hey guys, no fighting. Cats. This little orange cap here, what was that? That was $15 microfarads at 25 volts. I'll just make sure there's no voltage on that. Nothing. Good. See what this measures at. There's negative, negatives. 13.961, it could just be rating a little bit low because it's in circuit. Let's go up in frequency and just to 10 kilohertz. I can hold the probes on here. $11.8. That capacitor is either reading funny because it's in circuit, or it's actually started to dry up from the heat in here. Or maybe it's subject to some high frequency switching. I don't know exactly where it is in the circuit and what it's doing, so I can't say yet. It's died from heat or died from pulses, but it's died from something. I'm just going to move this 240 out the way, just so that we are safe here. This is neutral, so I'm not so worried about that. But I don't want that red one that's got the 240 volts on it. That's active. Here where I could touch it with my grounded soldering iron or whatever. So the thing is, if you look at the voltage between neutral and ground, there's basically nothing. But if you look at the voltage between active and ground, 240 volts. You don't want to touch that. So that's the reason why we're moving that out the way, guys. No, I'm not trying to take the piss out of those of you that understand electronics thoroughly. I'm just trying to educate those that don't. I don't think it's a wise thing for me to do dangerous stuff on the bench without explaining why it's dangerous. Because I don't want some young kid to go, oh, I might be able to fix my charger too, and then kill himself. Not that young kids should be watching this, because I have put my videos for only over 18s. But well, I said it not for kids, should I say. But still, I don't want anyone of any age, for that matter, to do anything silly just because they saw me do it and they thought they could do it. Alright. People said they wanted repair videos, so here's a repair video. Oops. Okay, so down at 120 hertz where it's supposed to be measured at, it's actually 15 microfarads. Yeah, that's just, I'd say that's just because of its capacitance. Generally with electrolytics, they have poor performance up in high frequency, and especially with a small voltage and capacitance value, it's going to even... Sorry about that, my phone just overheated and shut off, so I had to wait for the video I was uploading to upload, and then I could open the camera and continue recording this one. But you guys are just gonna only notice a second glitch of me saying the word even and then telling you this, and then we're getting straight back into it because I'm gonna splice the two videos together. But because my phone was charging, uploading and recording at the same time, it overheated. Anyway, what I was saying was about this capacitor is that it's going to be even worse at high frequencies. When you measure its specs, its capacitance and ESR, it's going to be worse at high frequencies, especially when it's a low microfarad rating and low voltage rating electrolytic. So that capacitor actually tests good, is what I'm getting at there. Whilst you guys were away, whilst I was away, I took some measurements. I also looked at the part of the video that I'd recorded and realised that the LCR meter wasn't in focus when I put the backlight on, so I'm just going to check now. Yeah, that's no good. I'll leave the backlight off. I didn't realise that, guys. I'm really sorry. You could just barely see the readings, but this capacitor here that I was going to use, as I was saying before, I suspected it might not be... What am I doing? I suspected it might not be up to the task, that it was just a standard electrolytic, and I think I'm correct, because down at 1 kilohertz we've got 41.37 microfarads, which is already shy of 47. Up at 100 kilohertz we've got 11.85 microfarads with 1.5 ohms of ESR, so that's out the window. However, I went to my inventory. You guys know how big my inventory is, and I just want to point something out. This is absolutely hilarious to me, because someone in the comments section, I posted a video where I took all the components off one of these boards. Yes, I still have another one. Yes, I just stole another 2 capacitors off of it. Anyways, these smaller caps, 4.7 microfarad X7Rs at 25 volts, and these bigger ones are 10 microfarad X7R at 25 volts. Really good capacitors. And what's moreover, those two 10 microfarad capacitors that we used the other day to fix the panel meter and the surface mount diode, they were harvested too for free. So the person in the comment section that said to me that I should buy my components in bulk and I'm wasting my time, I've got to disagree, because if it only takes me a couple of minutes to have a handful of components, and they're good quality components that work, and the commenter said, oh, why don't you go buy them in bulk? Well, why am I going to go buy 1,000 of these and 1,000 of these, and when I'm not going to use them? And also, you've already seen how big my component collection is. Could you imagine if I tried to stock 1,000 of everything? It just doesn't make sense. So parts I know I'm going to use a lot, like certain op amps and certain capacitors and that, I buy in bulk, or kind of bulk, like lots of 10 or 50 or 100, you know, and everything else just comes and goes as I need it, as it's harvested, as it's bought, whatever. And you know, like, as I said, if it takes me a couple of minutes to have a whole handful of components that would cost me about $50 to go out and buy them, and it's allowing me to fix things and build things, I don't see why it's not worth it. But anyway, that's not what this video is about, so I won't continue going on about that. And I'm not trying to have a go at you if you're watching, man. Like, I'm just pointing out what works for me, you know? If you're manufacturing stuff where you are making a lot of the same item or whatever, or doing a lot of repair work and going through a lot of the same component, then yeah, you want to buy in bulk. But I'm just about to start a repair business to fund the company I want to start. And in the meantime, I'm just building stuff for myself. So there's no reason for me to buy bulk, you know? So your mileage may vary, but that's my personal reason. That's not me having a dig at you. Yeah, I'm actually very happy that people are commenting, to be honest with you guys. I want feedback, I want comments, I want people to share my content. And I want to say thank you to everyone so far that has been doing that, because it's been very helpful and good to see. So I digress, I'll get back to the video now. The ESR, the LCR meter, it's measuring capacitance, and we've got the ESR value at the top here and the capacitance at the bottom, and I've got it up at 100 kilohertz. Now these are 10 microfarad capacitors, and they come in at 9.43 at 0.02 of an ohm. Let that sink in for a minute for the people who are trying to learn here. This is an electrolytic, 47 microfarads. But if we test it at 100 kilohertz, we get 11. If we go back down in frequency to 100 hertz, oh yeah, 44.75. This 10 microfarad cap at 100 hertz, it's still going to be, yeah, it's still 10 microfarads. But when we go up in frequency, all the way up to 100 kilohertz, this one still retains its value. And look at the ESR. Instead of 1.5 ohms, it's, excuse me, 0.02 ohms. So anyway, these are, like I was saying, 25 volt, 10 microfarad X7R capacitors. I don't have a solid polymer capacitor that's 33 microfarads at 12 volts to replace this one with. But what I can do, and it will perform even better, is I can stack all four of these together, which will give me 40 microfarads, so it's a bit bigger, at 25 volts instead of 12, so it's got more voltage headroom too. And being ceramic, these will last. And because of the higher voltage rating and the type of them, they have a really low ESR. It's probably going to be a lot lower than what's on there, what it will be. So what I'm going to do is I'm going to stack these up in parallel, like what I did with this panel meter, how I stacked a couple on top of each other there. I'm going to stack all four together, and then I'm going to add pins to it so that I can take this out and solder my new replacement capacitor in the board. This small one that I took out, there's nothing wrong with it, like the bulk caps, so that's going to go back in. I want to clean these holes up. I'm just going to wait for my desoldering gun to heat up, so I'll just pause the video. Alright, soldering gun's heated up, desoldering gun. So I'm just going to try and clear out those two holes where this capacitor's come from. Just a tip for people with a desoldering gun, always give it a bit of a clean out after you've used it, so little bits of solder don't build up in that narrow bit of tube behind the heated end of it, because it will block up and Then you'll have to pull it apart and take the tube out of it and then heat the back of the tube up with a flame and fling the solder out of it to unblock it, and that can be quite annoying, let me tell you. So those holes are clear. I'll just shine a light through the board. You can, actually it might be annoying, let me, I don't want to upset people by shining a light in their face, so I'll just not do that. But those two holes there. Oh, there you go. If only I thought about that in the first place. And there's a little plus there indicating the positive side, so we know which way to put it back in. That's the negative side. That's that going in. So now I'll solder that going in. So now that capacitor is soldered back in. Alright, so we're going to remove this polymer capacitor now. Oh yeah, that's one thing I meant to mention before too, guys. So, because seeing as this is a repair video and it's such a simple repair, I need to explain to people how I know without testing stuff what's wrong with this. Now I could be incorrect. There could be some other intermittent component failure, like one of these chips runs and then when it gets warm it starts to malfunction and the thing turns off. You know, that is a possibility. But usually when this happens, like I was saying before, the output capacitor, because it's subject to high frequency ripple, it gets destroyed very quick. And the smaller they make these things, and especially these, the quicker they get destroyed. So what usually happens with them is when they're just on the edge of being completely dead, but they're not quite dead yet, when they're cold, they will have some sort of capacitance value. Like this was a 33 microfarad. Let's say it had an ESR of 0.5 of an ohm and it's 33 microfarads. When it's cold, it might still be 22 microfarads and 0.8 of an ohm, and that might be just enough for the circuit to work. But then after it's been on for a bit and everything's warmed up, including the capacitor, all of a sudden its value goes down and its ESR goes up, and then what happens is the power supply shuts down. So that's why I believe that this is the culprit, just for those that are wondering. Because that's the thing about repairing stuff, is getting good at knowing what parts do what. So then when you get something broken, come to you to fix it, you can analyze the symptoms and go, okay, it's probably this or it's probably this, or at least you know areas to start looking. So it's good to learn this sort of stuff, guys. I'm just going to clear out those two holes there too now. I always clean my soldering, desoldering gun out meticulously when I'm desoldering boards, because all that lead-free solder that's used in everything these days, it really just gunks up in these things, and it doesn't. Yeah, it's nasty crap to work with. I really don't like it. I'm just going to find in my box of spare bits of component legs and jumpers and stuff. So that's why this box is here, because it comes in handy for stuff like this. A nice piece of tin copper wire that's the right size thickness. For these two holes, so we can form our legs. I'm going to try an interesting technique of getting these capacitors in here. We'll see how I go. You guys can watch. Bloody grips always come off these little cutters. Right. We'll put the other leg in. I don't like this material, it's not taking to solder very well. Usually when you tin up, yeah, no, that's really not. Oh, okay, that leg wasn't pushed through the hole far enough. Okay, that was my fault. I thought the solder wasn't sticking to this wire. I was going to take it out and use a different bit of wire. Alright. Want these guys to sit stacked up on top of each other. I'm trying to work out if I'm going to put them between the pins. I think I will. Yeah, that's what I'm going to do. I like that. I'm quite pleased with that. Sorry, I've just realised I'm getting my head under the camera again. I've ordered a huge, what do you call it, floor mount camera. What do you call it, tripod thing to hold my phone and stand it on the floor so it can look from like over there or over there. Am I going to be able to get this to work for me? Seems I was having better luck going straight down. Yeah. Yeah, that'll work nicely. Once I get one in here, all the rest will be really easy because I'll have a flat surface with the two sides to stack the rest on. It's all just about trying to bodge this first one in here. I was afraid that was going to happen. You know what? This wire isn't taking solder. You know what? These pins are coming out, guys. It's just not taking solder. I don't know what it is. I must have cut it out of some Chinese board and it's made out of steel or something. Either that or it's just really old and it's oxidized. But that's all good. I'd rather use something that I'm comfortable with and know it's going to stay there than just do a complete bodge job on it. We'll just take, actually, I've got some cut off resistor leads in here recent, just use them. Shall we? Does this tinned copper wire fit through the holes? Oh, you know what? That's an even better fit. We'll use that. Alright. This stuff I'm not too impressed with either. I got this from Jaycar. A lot of stuff there is crap. And it doesn't like to take like solder too easy. It's tinned copper wire, so it's obviously tinned with lead-free crap. So I usually go over it and tin it with proper leaded solder. I find it's the only way to get it to actually flow really well. Yeah, that's much nicer. Ah, yeah, that solders beautifully. That's exactly what I want. Alright, we'll solder the other pinion. Okay. So we're going to use those two pins because they are tinned with leaded solder and they work nicely. I don't think I'm going to get the capacitors in here the way I was planning on, by trying to sort of drop the bottom one in first and then stack them on there. I think I'm going to have to solder the capacitors to each other and then drop the whole pile in there and tack it on in one spot and then start soldering it. Yeah. That's okay. really don't like getting these things hot. Alright. Alright. So this is what I mean about soldering at a high temperature, or fairly high, 350, is because I can touch it so quickly, I can get it to flow without actually cooking the component. And it's really important for components like these that are sensitive to heat. Tell you what, this is tricky what I'm trying to do. You've heard that saying, if there's a will, there's a way. Beautiful. I'm just going to wait for that to cool down a bit more. I can touch it, but it's starting to get hot. And because the construction of these capacitors, they're so small and compact, and it's a multi-layer ceramic capacitor. So inside it, it's literally alternating layers with a little dielectric insulator in between them. And that's all smooshed up and squished together, and then one lead comes off one side and the other lead comes off the other side of the plates. And there's literally thousands, millions, like hundreds of thousands squished up in one of those little packages. So you can really, really damage that quickly with too much heat. So that's why I'm really cautious. If I've got to do a lot of soldering on something that's like this, I won't just hit it with heat and blast the hell out of it. See, that's already enough heat in my opinion for that. Even though I haven't finished soldering that last bit, I will wait. There's actually a little bit of crap on there. It's a bit oxidized. That should take solder perfectly now. There we go. That is my 40 microfarad capacitor. Still pretty hot. Now, just to show you how amazing the properties of this homebrew capacitor is, we'll go back to the LCR meter, we'll go to capacitance, and we'll have a look at capacitance and ESR, and we'll see what we got now. 40 microfarads, 0.05 of an ohm. I guarantee you it's not 0.05, it's not gone up, it's gone down. Like the solder junction to this gold plated brass or whatever it is adding resistance. If I can get it a good connection, see I can get it to go to 0.8, 0.4. Oh, that's at 1 kilohertz. Sorry, I didn't put the frequency up. I was digging the clips in harder and harder, going, why can't I get this on there? Oh, come on. Well, that doesn't make sense. I don't think these leads are getting on here. Actually, I think what's going on here is I think the ESR is so low now that it's actually not able to measure the capacitance. Let's try it at 10 kilohertz. Yeah, see, 0.01 ohms, 38.6 microfarads. We know that's a ridiculous capacitor now, so that's probably like 0.05 ohms or 2 or something, literally at 100 kilohertz. It's like with the meter is confused because it's basically appearing as a short circuit and it's throwing the meter off. Alright, now we've got to get this in here. Shouldn't be too hard. Just sort of bend these pins into a way that looks like it'll work and solder it in. I wouldn't mind them being more level. So not level, but in between the leads, yeah, like that. Yeah, I'm very happy with that. Oh, my soldering iron's gone to sleep. You know what? Ah, goodness. I'm just thinking I need something to hold the board, and all my little clips are holding bits of breadboard together and to the shelf above here, above my work area so I can hold the phone, because I don't have a holder yet. But this big clip will do the job, so we'll use that. Alright, we'll just tack it on in a couple of places quickly so that it can't move whilst we go and solder the rest of it. I hope my head's not in the way. Oh, it probably is, eh? Oh yeah, I've been doing it again, haven't I? It's just, I find it very awkward to lean back. This is why I can't wait for the camera stand to arrive. It'll be here tomorrow. Oh, no, it's a public holiday today, isn't it, in the weekend? Should be here on Monday. So, at the worst, I think 3 days. Oh, 2 days, should I say? And you guys won't have to worry about seeing my head in the way anymore. Wow, that came out way better than I expected. I'll get you guys an up-close shot in a sec. I'll just trim the excess lead off the top, and the height of it came out perfect too. This is great. So you don't have to throw your tech away, you can fix it even. All this newfangled miniaturized stuff. If you're good with your fingers, just look at that. There's a space in between the side of the capacitors and the USB port. And the capacitors are all nice and neatly stacked up between the pins. You can't ask for a better replacement, can you? So that's that. So you know what we've got to do now? We're going to make sure it still works. Before we do that, we always double check our work. So this is the polarized capacitor I removed, electrolytic, but it's polarized. We'll make sure it's in the right way. And yes, the positive pin's on this side, positive there, that's correct. These don't have a polarity, so it doesn't matter which way they go in. And we haven't changed anything else other than the bit of silicone glue stuff that I moved out of there. That's just to stop these guys from rattling around. Oh, hold on a minute, these are two different value capacitors. One moment guys, we might have to do some more testing. Well, we do. Are they in parallel? Yes, they are. One's 15 microfarads. Oh, the other one's 12. So they're both in parallel. Let's see, 120 hertz. What do we get? We should have about 22 microfarads if I'm right. Sorry, 27. Yeah, 27 microfarads. $23.23. I wonder if that's because they're in circuit. Let's see if there's any resistance across that. It looks like there's resistance across it. I'd say that's throwing the reading off. I'm gonna just put my multimeter over where my LCR meter goes. I'm gonna say that's fine for now. I'm gonna obviously power it up quickly and we'll see if it works. Just plug my active wire back in. I unplugged it because my cat was in here and one of my cats stressed me. And I don't want my cat to go, hey, what's that, and play with it and then die. Oh, just caught it. I don't know if you heard that little pop, but that was the active wire making contact. So now we're going to look at our output. .00 7 volts. So it's still working. Alright, well, I'm going to put that back together. I'll just unplug these dangerous live cables first. That's better. Put them off to the side. Alright, I'm going to slide this back into its case. Just want to see if the spacing on the pins is tight still. Yep, I'm happy with that. You know, sometimes I do really dumb things. Let's get rid of some of this mangled up plastic. Alright, so this slides in here and then clips into the terminals at the front, like so. Look at that, my capacitor bank even fits in there perfectly. And then the very much ruined top piece, which I'm just going to probably put in with super glue for now or something like that. I can even get it back in. I think with a little bit of work I'll be able to get this back in to the point that I can glue it in. Try that. Yep. I'm happy with that. Alright, I'll just go get some super glue, one sec. Okay, I'm back. Cyanoacrylate can be so handy. I'll tell you what'll suck if that wasn't actually what was wrong with it. I'm not that bothered, honestly. This actually broke probably, I'd say at least a year ago. and I hadn't got around to fixing it until now. And even then, to be honest with you, I thought I'd just do it because I don't believe in fast charging my batteries, but it's always good to have a fairly fast charger around for that one emergency when you do want to charge your battery fast. The reason I don't like doing it is because it destroys the battery quicker. But anyways, yeah, I thought this would make a good little video. So there it is, the Samsung charger repaired. If I had a second phone here, I'd plug this in and plug it into a phone. But I mean, you've already seen it powered off of the mains and the 5V output, so you know it works. And I'll let you guys know on my next video if this fails or if it continues to work, because it basically got to the point where it would only charge for about 2 or 3 minutes and then it would just turn off. So I'll know within a day at the most if I have solved the problem, and I'll let you guys know. That's it for this video, so I'll see you guys in the next one. Have a good time.